Hello everyone, let's answer number 77. Quadratic functions are useful for modeling projectile motion, that is, situations in which an object is thrown or launched into the air. The force of gravity causes the object to accelerate or speed up as it falls towards the earth and decelerate or slow down as it moves away from the earth. A general equation for projectile motion is written as f of t is equal to 1/2 a of t squared plus v sub 0 t and h sub 0. In this equation, a is the acceleration due to gravity, v sub 0 is the initial velocity, v at 0 is the initial velocity, or the velocity when t is equal to 0. H sub 0 is the initial height when the height when t is equal to 0, and f of t is the height of an object at time t. For letter A, write Al's equation in standard form. So remember, Al's equation is h of t is equal to negative 16 t minus 2.25 squared plus 81. If we are to write this in standard form, our standard form is as f of x is equal to ax squared plus bx plus c. So this is the vertex form or the graphing form. So we are to write it in this form. So to write it in that form, first we need to expand this. So negative 16. So when we expand, this is t minus 2.25 times t minus 2.25 plus 81. So this will be negative 16 when you expand t squared, that's t times t, and then t times 2.25, so negative 2.25 t, and then the inner, just apply FOIL method. This is negative 2.25 t again, and then we'll multiply this. That will be 2.25 times 2.25 will give us 5.0625 plus 81. And then we will multiply 16. We'll combine this. This will be negative 16 t squared minus, when you combine, that's 4.5 t plus 5.0625 plus 81. So multiplying each term, we'll have negative 16t squared, and then multiply that. So 16 times 4.5 will give us 72. So that's positive 72t. 16 times 5.0625 will give us 81. So negative 81 plus 81. As you can see, we can cancel this. So our general equation will be h of t is equal to negative 16t squared plus 72t. So this is our answer for letter A. Okay. Now for letter B, write Shar's equation in standard form. Remember Shar's equation was h of t is equal to negative 16 t minus 2.25 squared plus 81. We just added 15, and that's why we got h of t is equal to negative 16 t minus 2.25 squared plus 96. So if I don't have this, this will be equal to this. When you expand, I'll just add 15 in here. So if you wanted to make it a little shorter, your h of t, since we added 15 here, we just add 15 on the general form of Al. So this will be negative 16. So we don't need to expand this. This will be t squared plus 72t plus 15. So that would be just add 15 here. Because we just added 15, that's why this is the equation of Al. We just add 15 here. When you expand this, this will become the same. These two are just the same when you expand. Now, in your equation from parts A and B, what do the coefficient represents in terms of projectile motion equation given above? So this negative 16 is half the value of the acceleration due to gravity. So we know that this is 1/2, okay, of A, acceleration due to gravity. So we know that your negative 16 is half the value of acceleration due to gravity. Okay. Now this 72 here and here, we know that the velocity at v sub 0 is the initial velocity. The velocity when t is equal to 0. So if we have 72t here, therefore the velocity, initial velocity, is 72. Okay, so when we say velocity, we are using feet per second, I think. Okay, from the original balloon height or balloon launch. So the next one, your 15 here is h height when the balloon, h sub 0 is the initial height when t is equal to 0. So here, we have 15 because remember Char started at the bleacher in 15, and in here, there's no plus 0, so it started in the ground. But here, 15, so h sub 0 is 15. This is where the height in feet of Char's balloon when it was launched. Okay, so hopefully that helps. That's the last part of the guided practice for 9.1.3.